Bismillahirrahmanirrahim. Hello everyone. My name is Abdullah Al Rafi. I am a student of software engineering. I am currently studying in Noakhali Science and Technology University. Today we will explain an interesting topic in data structure, that is Tower of Hanoi. So first of all, we have to understand what is Tower of Hanoi. Tower of Hanoi is basically a puzzle or a mathematical puzzle, we can say, or it is a game. It is a one kind of game where we have three dots or pillar. Sometimes it's called rods, or in some places it's called as a pillar. And in these pillars there are n discs. So for the better understanding, we can see a picture of Tower of Hanoi. So it is a visual representation of Tower of Hanoi. We can see there are three pillars here. This is the first pillar, this is the second pillar, and this is the third pillar. The first pillar is called source pillar, where there can be n number of disks. Here there are 4 disks, we can see 4 disks, and we have to move all these disks according to some rule to the targeted pillar, and we can use this auxiliary pillar for moving this disk. So what is the objective of Tower of Hanoi? The objective of the puzzle is to move the entire stake to another rod or pillar, obeying the following rules. There are some rules to move this uh, disk in the primary pillar to the our targeted pillar. So the rules are, the first rule is only one disk can be moved at a time. So if we have three pillar, here is the first pillar, and sorry, we have to erase this. So I can use the pencil again. It is our second pillar, and this is our third pillar. And let us assume that this is one disk, this is another disk, and this is another disk. So we can move only this one disk. This is number one disk. So we can move this disk from this tower to any of the two tower. We can move only one disk, but at a time, at one move, we cannot move more than one disk. So it is our first rule. And the second rule is, each move consists of taking the upper disk from one of the pillar or rods and sliding it onto another pillar or rod on the top of the another disk that may be already present on that rod. So for a better understanding, we can draw another picture of this. So this is our first pillar, this is our second pillar. So here there are, we can say there are two disks. So we can only move the upper disk. We can move only the upper disk from one pillar to another pillar. We cannot move the bottom disks. We cannot move the bottom disk, or that means we can only move the topmost disk of the pillar. This is our second rule. And the third rule is, no disk can be placed on the top of the smaller disk than itself. If we have three pillar like that, so let us assume two pillar. So it is it is a bigger disk. It is smaller than the first one. So if we can represent it as 1 and we can represent it as 2, so we can move this from here to this pillar. Now the first, in the first pillar, if we remove this, in the first pillar we have a bigger one and we have a smaller. In the second pillar we have a smaller one. So we cannot move this big disk on top of this pillar. So we cannot do this. This is our third rule. Only the small element can be put. So this is our last rule for this game or puzzle. Now we can see we will see an example of the solution. How can we solve this problem from the primary or our main pillar to our targeted pillar? How can we move all the disk? uh, Let us consider there are three disks here. This is the first one that is marked as green. This is the second one, and the last one is the red one. So we can assume that there are three disks in our primary pillar or primary dot, and C is our targeted pillar. Okay, and B is here our auxiliary pillar. So the steps will be in the first, move one green from A to C. So we can move this topmost element from here, from A to from C. So we can move that. So the picture will be like that. For the first move, we can see the green disk is moved from pillar A to pillar C. In the second move, um, number 2 disk will be moved from A to B. So there are this disk can be moved. Only one option I have, or we have. It can be only moved from A to B, because we cannot move this A to C because it is the bigger one than the green disk. So we cannot move it from A to C. So we have to move this from A to B. It is our second step. So in the third step, move 1 from C to B. So we have to move this element, this red element or this red disk. We have to move it from C to B. Sorry, move one is the green one. The one is the green one, purple one is the second, and the red is the third one. So we can move this from C to B. So it is moved from C to B. In the third step, so it is moved from C to B. Here we can see C to B here. And in the fourth step, move 3 from A to C. So the bigger one, it is the third one. So third one is moved from A to C. The second picture we will see that. So we can see that the bigger one is moved from A to C. In the fifth step, move 1 from B to A. So this is green one is the number 1. So it is moved from B to A. So it is moved here. In the sixth step, move B 2 from so purple one or this one is moved from B to C. So it will show here. Okay, and in the last step, move 1 from A to C. So green one is number 1, so it is moved from A to C. By this process, we can able to move these 3 disks from the pillar A to the pillar C by using the pillar B. It is a possible solution of our Tower of Hanoi. So now we can we will see a code for Tower of Hanoi. How can we solve this problem by a program? We will see it in the code blocks. We will see in the code blocks. So okay, this is our code. So this is our code. I write the code in C++ languages. So if we go back to the code blocks for better understanding, so it is our main code. We write it in C++ languages. This is our main function for solving the Tower of Hanoi. I use a recursive process to solve this problem. Here we are taking 4 parameters for the function integer n. Integer n is our number of disks, how many disks we will take, and character from rod. This is our primary rod, this is our targeted rod, and this is our auxiliary rod. AUX rod is referred by auxiliary rod. So If n is equals to 0, then this code will return nothing, and if n is greater than 0, then what can we do? The Tower of Hanoi, if n is greater than 0, then Tower of Hanoi will call itself, and it will decrease 1. If it is 3, then in the first line it will be 2, and it will, from rod using the auxiliary rod, it will work 2 rod, and it will print the first operation. And in the second operation, we will again call our Tower of Hanoi, and it will decrease the first one, the number of disk, and it will be used as auxiliary rod to the 2 rod from rod. So it is our main function, and here it is our main function, where we will use n is equals to 4. N is for the n is equals to 4, we will run this code. So if we run this code, then output, here we can see that the output is here. That is this output is shown in our picture previously explained. So for better understanding, we are coming back to the PowerPoint. This is our code, this is our main function, and this is our output. So now we will discuss about the recursive call that is shown here. This recursive call, I have to mark this line, and the printing line, and this the third line. These 3 lines is the main fundamental thing of Tower of Hanoi. We'll explain this recursive call in the next slide. So these are our main things. For n is equals to 3, for 3, we will discuss this recursive call. So first of all, for n is equals to 3, we are performing this recursive process. So first one is for the first recursive call, it will be n minus 1. So n minus 1 will be 2. 3 minus 1 is equals to 2, and ABC will be ACB. So this is ACB. This is our first line. For the first line, this will transfer to this one. This will be transferred to this one. In the second line, it will print A to C. So A to C is printed. And from the third line, for the third line, it will perform n minus 1. So n minus 1 is 2. 3 minus 1 is equals to 2. And BAC, ABC will be BAC. So this is the first recursive process of Tower of Hanoi. And in the second recursive process, so again n minus 1, here n is equals to 2, and n minus 1 will be 1, n minus will be 1, and ACB, it is A, it is not C, it will be B, and it will be C, and ABC will be converted into ACB. So A is here A, and C will be our B. So B is here as ACB. If we write to ACDC, and then it is B. So for mapping this, it is A, it is our B, and it is our C. So it will be like that. And in the second line, it will print A. Here A is A and C is B. So A and B will be printed in the second step, the second recursive in the second step. And in the third line, for the third line, BAC will be printed. N minus 1 is equals to 1, N minus 1 will be 1, and BAC will be printed like that, CAB. And for the in the second recursive call, for the second line, this line, again three line will be executed. So first one is n minus 1 is equals to 1, and BAC will be BCA as ACB, and in the second line the B A to C, A and C will be printed. So here B is A, and last one is our C. So B to C will be printed. This is our first move, this is our second move, this is our third move. Okay, and then again the recursive call will be performed. This is n minus 1 is equals to 1, and B, and it will be ABC. So BAC become ABC. And for this recursive call, again the tower of Hanoi will be called, and n minus 1 is equals to 0. Here n minus 1 will be 0, so no action will be performed. And so for the first line no action will be performed. For the second line, A comma C will be printed. So here is A is A and C is C. So A comma C, A to C will be performed. So this is our first, second and third. This is our fourth move. This will be our fourth move. And for the for this one no, as it is n minus 1 equal to 0, no action will be performed. For this one, the left recursive call and the right recursive call, no action will be performed. Only for the middle line, C to B will be printed. C to B will be performed. It is our next move. And for this and this, no action will be performed. Here no action will be performed, as it is n minus 1 is equals to 0. Only the second line, printed line will be printed. So here B to A will be printed. Okay, so same goes to this recursive call. Only A to C will be printed. So here A to C will be printed. So this is our steps for solving tower of Hanoi process. I am trying my best to explain this recursive call. I hope you all understand this. Thank you everyone for seeing this video.